Hey gang, let's talk about solving right triangles using trigonometry. So if you're trying to solve a right triangle, first of all, you need to have a right triangle. So let's say we have this right triangle here. And you need to have the right angle and two other pieces. The only case we can't do is if you have both acute angles. If you've both acute angles, you can't find anything about the sides. So you need two other pieces, at least one of them has to be the side. So let's say we had an angle and we had a side. So let's say this angle was 53 degrees and the hypotenuse was 13. So we want to solve this triangle. So we know two measures, and a third measure is very easy to find. That right angle is going to be 90 degrees. So what we're missing is we're missing one angle and two sides. Well, if you know two angles in a triangle, we know what all three angles add up to. They add to 180, and if one of them is 90, that means these two add up to 90. So to find out this angle, you can subtract 53 from 90 and get 37 degrees. So we have all three angles, but just one of the sides. And we haven't had to use any trig yet. But to find these sides, that's what we're going to have to use the trig for. Now, if I'm going to use trig, I like to use what we're given. The two things we were given are the 53 and the 13. With respect to that 53 degrees, that 13 is the hypotenuse. And we're missing these two legs. With respect to the 53 degrees, this leg is the opposite, this leg is the adjacent. So we're going to use trig to find the opposite and the adjacent, but all we know is the hypotenuse. So we need to think back to which two trig functions use the hypotenuse. So if we think to SOHCAHTOA, so sine is opposite over hypotenuse. Oh, that's good. That helps us. So sine of 53 equals the opposite. I'm just going to use the variable p for opposite over the hypotenuse, which is 13. And then also cosines, cosine is adjacent over hypotenuse. So cosine of 53 equals the adjacent over the hypotenuse. I just used the variable a for adjacent. I didn't use o for opposite because that looks like a 0. So we need to solve these. So p equals 13 sine of 53. A equals 13 cosine of 53. I'm not expecting you to know what sine and cosine of 53 degrees are off the top of your head. These are things we're going to need to use our calculator for. So, if you have your calculator, you should be in degree mode. If you don't know how to change the mode, if you have a TI 83 or 84, the mode button is next to the second button, and then you just scroll down, it's either radian or degree. We want to be in degree mode, I already am. So we'll use 13 times sine of 53, 13 sine of 53. And that is 10.38. So I'm just going to label that there. And then 13 cosine of 53 is 7.82. All right, so now we have all three sides, all three angles. We've solved our triangle. So we only had to use trig for two parts of it. Only had to use trig for two parts. So that's if you have one side and one angle in your right triangle. Now you can't have two angles because then it would be an infinite number of triangles that would satisfy it, but you could have two sides. So let's say this is 7, and that's 25. So if we want to solve this triangle, one of them is very easy to find, this angle. That's 90 degrees. But then the other two angles are not so easy to find. The next easiest thing to find would be this third side. We would just need to use the Pythagorean theorem. So 7 squared plus b squared equals 25 squared. 49 plus b squared equals 625. So b squared equals 576. So that means b is the square root of 576, which is 24. So that's 24. Now we want to find the angles. It doesn't matter which angle you choose. I'm just going to choose this one right here. I'm going to call that theta. So with respect to that theta, the 25 is the hypotenuse, the 7 is the opposite leg, and the 24 is the adjacent leg. I always like to use the 2 we're given, just in case we made a mistake finding that 24. We didn't, I know that is 24. But just in case we made a mistake, I always like to use the 2 that we started with. So 7 and 25. So it's the opposite and the hypotenuse. Well, SOHCAHTOA, opposite hypotenuse, OH, that's with S. So it's sine of theta equals 7 over 25. So now we want to solve for sine. So to undo sine, if you think back to when we first covered this, to undo sine, you need the inverse operation of it. That's sine inverse. So theta equals sine inverse of 7 over 25. I'm not expecting you to be able to do that without a calculator, so we're just going to use our calculator. Second sine. The sine inverse, cosine inverse are the second options of sine, cosine, tangent. 7 divided by 25. So it's 16.3. So this one's 16.3. And this, well, we have 2 angles. You could use trig to find that. But for this one, the 7 is adjacent, so you do cosine of this angle equals 7 over 25. But why go through that work? If you have 2 angles, you can find the third because they add up to 180, or the fact that the acute angles add up to 90. And 90 minus 16.3 is 73.7. All right. So as a refresher, you use your Pythagorean theorem to find your third side, and then you can use trig using the 2 sides that you had. To undo sine, you do sine inverse. If it were cosine, you would use cosine inverse. If it were tangent, you would use tangent inverse. So that's when you have 2 sides given to you. If you have a side and an angle, you can find the measures of the missing angles, just because these 2 add up to 90, and that one is 90. And then you can use the 2 trig ratios that use whichever side you're given. So if you're given the hypotenuse, that's sine and cosine. If you're given the opposite, that's sine and tangent. And if you're given the adjacent, it's cosine and tangent. And then you would just solve the rational equation that's left. Try to isolate that unknown value. All right, that's it. Have fun.